Okay, so we will start with our lab. So in person, I guess it's just one student, but this is being streamed. So the focus of homework 5 is HTML tables. And so let's take a basic look at. So we will load our data set here, which is basically a data set of all different Nobel laureates. Uh, we can use the observables inbuilt inputs.table function to kind of plot the data, and we see that we get a really nice table. But this table essentially is just part of observables. We can't really use it directly in JavaScript. And you can see the table is nice, but it doesn't really support anything apart from like reading the data. A lot of the data is truncated. So let's take a look at how we can create our own tables in HTML, which is essentially like a big part of your assignment this time. In HTML, a table is denoted with a table tag. Just as we have divs and paragraphs, we have a table element. And HTML basically wants to specify a table element, we can now encode row and column data inside it. The two main parts of a table are the header, and the body. There is also an optional footer, but we don't really need to get into that. It's not very used. So a header essentially houses your columns, name of your columns and other metadata. And if you think about it, a header and a body are not really that different internally. Of course, there are some minor differences to styling, but you could essentially style one row of the body as if it were the header. The reason why we use header and body separately is so that accessibility softwares can actually separate a table into a header and a body and then read them out separately. So a header of a table is denoted by the T head component, and each element of the T head component is the individual name of the column or individual column. So this can either have the name of the column, or you could replace it with something fancy if you want. And same with body. Each element in the body is a row of the table, and the row itself is represented by TR. And each row in turn is composed of TD elements, which actually have the values of the table, or you can think of them as cells of the table. Now, so you can see the elements of the table are kind of are prepended with a letter T. So T head, T body. Similarly, we have TH, which says like T header, or TR, which actually means T row, like table row. And the TD itself, essentially, you can think of it as T data or just data element. So yeah, so this they individually they don't really mean something different. All they represent is, you can think of them as just all of them are like divs, but with slightly different meaning. You could essentially do all of this by individually writing divs and giving them a style. But you should always use a table element so that screen readers can essentially differentiate and read the tables properly. So now let's take a look at how to create a static table. We have our table element, we add our header and our body, and let me just remove the body for now and see how the header looks. If we comment our body out and run, we can see we just have a column A, column B, column C. And again, we see the columns have like an underline which separates it from the body. All of this is actually done by observable. A basic HTML table doesn't really have a style. It just lays them out correctly. You kind of have to take care of the styling. And now if we uncomment this, we can see the body comes back. And as we saw earlier, T head contains three individual TH elements, which are the column names. If we update this, we can see the appropriate column updates. Similarly, the T body has three entries, like three top level TR elements or three rows, which you can see on the screen. And each row itself has three values for each column, A1, B1, C1, and etc. So we can see this is a way we add a static table, right? So doing this for our data set manually would be quite tedious to write all of this nested elements. So we use the D3 enter, exit, update, or D3 join syntax, as I'll show you today, to kind of make our life a bit easier. And you can see how small, surprisingly, the code for actually rendering a large table is. So let's start by loading our data set. which was the data set of different Nobel winners. If we open what data, we can see it has different values, such as the year in which the Nobel was won, type, the type of Nobel Prize it was, the name, birth date, birthplace, and all different data for the Nobel laureate. Like in our example today, like we don't really care much about the actual data. So we have this filtered. So we take our data and we filter it to remove elements which have no data values for residence and role and affiliate. This is just so that our data set becomes short, because the original data set is already, if we look at it, it's already 839 elements, which is quite a big table. So we filter it down and we end up with 84 elements. We still filter it down to just have 10 elements. Since it's observable, we can update this to 20 and it shouldn't really make a difference. Our visualization should update. If you just remove this dot slice, you should be able to visualize all the data set. So now let's take a look at what we want to do first when rendering a table with a D3. First thing, we always get a separate list of the columns, because we need to render the columns separately. So to do this, we take the first element of the dataset and we essentially use object.keys function to kind of get all the different properties, and if we expand our original object, we can see basically the number of columns are basically the different properties in this object. So we just use object.keys to get the name of these properties in a list. Questions? Okay. Yeah, so this gives us our list of columns, and then instead of using the columns directly, we have a dot map function here where we map. So if we look at the original output, it would look something like this. Yeah, it would just be an array of different array of different basically names. What we essentially have here is a map function which takes each column and maps it to an object with a title property, which is the original column, and another value called sorted, which we set to null. So what we will do in this example is we will essentially track the sort state of our table, and we'll see how to do that. So by default, sorted would be null, which means our default table would not be sorted on any particular column. But depending on when we click on different column headers, we would set the behavior to sort it either in ascending or descending order. And I have like a note here. So if the column can either be sorted by ascending or descending, or if it is not or if the data is not sorted by a particular column, the value of sorted key should always be null. Yep. Mhm. Yeah, no, subset is taking the first data. So our data has 20 objects right here. So if we open this, so subset is taking this entire first row. Yeah, entire highlighted part. Mhm. What do you mean? Yes. Yeah, it has year, category, name, birth date, all of it. Yeah. Yeah. So, yeah. So we basically now have this list of columns, and we basically mapped our columns to instead of just using strings, we mapped it to an object where we can now track if a column is sorted or not. And for now, the value of sorted key is null, which means our data is not sorted at all. And we'll see how we update this sorted key to kind of track which column is sorted. So now we go on to render our actual table, and this is the table we'll have initially. It has no interactions, clicking does nothing, just a simple table rendering. And let's see how it looks like. For now, I will also go up and basically set our data to just use the first 10 values so that we don't have to scroll as much. So yeah, so now our table is much shorter. So we start by creating a div to kind of house our table. Then to this div, we append our table element, which basically initializes our tables. Then to the table element, we append a header and a body. And at this point, we have an empty t head and an empty t body component, which represent header and the body. And then appending the header is basically doing a select all th, join the data, which is the header data is the actual list of columns we came up with. And then we join it. So we use the join syntax here. So instead of doing an enter, exit, or update, we just say join, which adds or removes everything as per the data binding. And then the text which should be rendered in the column is basically the d dot title, which we set here. So this is what will appear. If we didn't, if we basically decide to, if we decide to not do this map, we could just use d directly as the value. And that's basically just a simplification. That's basically just a simplification we did so that we can basically add this d dot sorted later, right? So, sorry. Yeah. Mhm. Yeah, so I'll show you why it's required. So right now, it seems that it's just adding a complication, right? Instead of using directly, we are mapping it to title and then using d dot title. So in the next step, here we see that to set the sort class, we are using the d dot sorted property. Again, this is the first example, and d dot sorted is kind of useless, right? D dot sorted is actually null. It actually does nothing. So we will see in the later examples how we use this sorted key we added to kind of actually sort our data set. Yes. What do you mean? Yes, we will go through them when we actually use it. Like right now, we are not using sorted at all. So in like this example, we are not using sorted, so we'll just forget it. And when we go to like the other example, we'll see why this adding this extra sorted key was useful. And the reason we had to add title was because we wanted to add sorted. We wanted to replace the string with an object. So we took the title string and put it inside an object with and assigned it to like the title key, essentially, which basically may which instead of like basically using this, we have to now use this. That's the only thing that's added, but it makes our life simpler later on. So at this point, yes. So at this point, we have added all the th elements, and we can just do a quick inspect element and take a look at it. Yeah. So we can see that to our t head element, all the elements inside the columns array were added one by one, and their values were set to the proper values. Then in the next part, we do the similar thing for body to add our rows. So th was just adding the column, adding the header. Now to add our rows, we go to the body, we select all the tr elements. So as is earlier, tr represents each row, and then we bind it to our actual data, which is the subset, which is the first 10 rows we selected, and then we join it. So and then we use the join syntax to kind of get like append empty trs. So at this point, you see we did not actually append any of the actual data. We just said for each entry in our subset, append a tr. We are not actually rendering anything. So just to see, for example, if I comment this out and if and just let this run. Yeah, if I comment this out, yeah, so we see the actual table disappears. And if we go to the inspect, we have our t head and th, but in the t body, we just have this empty tr elements, because for each element in the data, we created a tr, but we didn't actually add anything to it. So now let's add something to each tr. Now, if I uncomment this, we can see for each, so what we are saying is for each row or each tr element, select all the tds inside that tr, bind it to the data, and in this case, the data is actually derived from the subset which we bound earlier. So the data is basically, if we console log the data here, if we go to our console, clear everything and run this, we can see the date. Where did this go? Yeah, we can see the data is actually the individual object which we bound earlier. And what we are doing is, instead of returning the data directly, So what we are saying is convert this data into this array of individual values, because D3 can only bind arrays. And then inside each TR, we will bind this array of values to a TD element. And then the value of the TD element would be the first element of this array we created. And the way we are converting our object D here, which we see on the console, to this array of arrays is using object.entries. We could also replace this by using object.values and then just use the T directly, and it should just still give us the same exact result. So this is essentially up to you, like what do you want to use, object.entries or object.values. I used object.entries, so I could show you that this object is being converted into this array of arrays. And the reason we have to do this essentially is to kind of map individual cell using D3 syntax to our object, because D3 cannot bind to object directly. So we convert the object to an array and then bind the array itself. And now if we do an inspect element here, and take a look at our table, yes, our T head is correct. And if we open our T body, inside each TR, we kind of have this TDs added to it. Okay. Does that make sense? Yep. And we see our table is really ugly, right? Like our table doesn't look good. It's like really squished together. It's hard to read. So let's just style the table a bit. So we are adding a couple of styles here, and I'll go through the styles to show you kind of how to create some good looking tables, maybe for your project or like future assignment. So see, this is the final output we expect, where we have a table with alternate colors in the rows, so we can easily differentiate between rows. When we hover, the color of the rows change, the color of the text inverts, so that we can still read it properly, but we know what is selected. Everything is center aligned, and of course, like the table requires more space, so you can scroll, but text is not squished anymore. So essentially, the rest of the actual code here is exactly the same, except that we gave the table a class called table style, and in the actual CSS, we kind of start assigning stylings to this selection. So to the entire table, we say that add a property of overflow X, which means if the table expands in X direction and goes out of the screen, give us a scroll bar. This is pretty like basic, so that if we don't do this in observable, it cuts off our table and we can't read anything. Then we say text align its center, which basically centers our text so that it's not aligned to one side. This is basically a style choice. You can leave everything left aligned. It's up to you. Then what we're saying is, for all the th elements in our header, basically give a padding of 10 pixel, align everything to center, and set a minimum width of 150 pixel. So basically, let's just comment this and add it back one at a time. So actually, yeah, let's see what happens. If we remove this style completely, we end up with this squished together table. Now, if we just add back the padding of 10 pixel, we slightly space out our text so that the column label doesn't touch the edge of the actual rectangle. Next, we have our text align, which basically aligns everything to center. And when we say the min width is 150 pixel, what we're essentially saying is, if our table column requires more space expanded, but it should never be smaller than 150 pixel, this kind of basically lets your table be slightly uniform. You can replace min width by actual width, and what that will do is essentially set all columns to 150 pixels, and if the content of the column is bigger, it will wrap. So it's up to you. It's again a design choice. You might have one column wider than others, but still never below a certain threshold. That's what min width does. So it's kind of up to you. Then this is the code which actually alternates the colors, and we actually, oops, let's go back. Yeah. So this is the code that actually alternates our color of our rows. And actually in CSS, you don't really have to do something fancy to do this. All we are saying is, for inside our body, like inside the T body, for every even number of row, set background color to be this. That's all we are doing. And this automatically sets even. And if we want to switch the order, we can just switch this to odd and it will invert the colors. There are other values you can use here for nth child. So you could like basically say the third child or the fourth child exactly. But even odd kind of use you to like let you do this alternate thing. And yeah, like as you can see, it's not a lot of code. It's just one line and you basically get this really fancy looking table. And if you see like this table style is used in a lot of, for example, if you use Keynote in a MacBook to make your presentation and you add a table, the default style for Keynote tables is this alternate coloring, which makes it easy to read different rows. Choice of colors again is up to you. Then this code basically adds the hover. So what we are saying is inside the body for any TR, when hovered, essentially give a background color of this. So when we hover, the background color changes. Then since we are using a dark background, we need to change the color. Color represents the color of the font to be white, which is FFF in Xcode. So it inverts both the color and these two kind of basically, you can see that if I comment out the border colors, it's really hard to read it's when I hover, the border basically becomes invisible because border color kind of starts matching the background. So basically what we are doing here is this original border color was 000, which is like black. We are changing it to 255 255 255, which is white, and we are adding the opacity so the border isn't as dark. So if you see, if I kind of hover, it feels the border isn't changing color, but border is actually going from black to white. It just appears because the backgrounds are so different. Yep. Yep. Mhm. So margin of victory is essentially an SVG, right? So basically you have to create a plot for it. So it's a SVG, right? So so when we are appending things in the table here, instead of appending a text, you append an SVG, and then like you know how to actually draw things inside SVG already, right? Yeah. Hmm. Hmm. Yeah. Yes. Yeah. So it's, well, I mean, answer is always yes. It depends. You can do two SVGs, but just doing one SVG is easier, right? All you have to do is use the scale property somehow to figure out where this lies. Like you can use the scale to figure out if this is greater than the middle line, or like is it to the right or is it to the left of the line, and then decide the color. Does that make sense? Because you already have access to the scale, right? So basically you're like, you can think of this like in our previous assignments. uh, this would be similar to like the code which you used for determining position of the labels in our COVID homework, where when the line approached the edge, you switch the position of the labels from right to left. Yeah, so it's similar logic, right? You find a point on the screen at which point you want to like do something, either A or B. In this case, the middle of that SVG is your red or blue deciding factor, and you use scales for that. Like that's how you determine where your SVG is, right? Yep. So yeah. Okay, so yeah, so this was like the code for style, and then now the last part here is the actual code for our interactions, right? So the interaction we are adding here is this. If I click on the header, it appends an A or a D depending on whether we have sorted ascending or descending, and then it actually sorts. So this is also same value, but yeah. So if we see it, Yes, so well, so that's slightly yes, it sorts alphabetically. More accurately, it sorts it in a lexicographic manner, because JavaScript by default uses lexicographic sort. And I'll show you this where we add the sort, and you can just change the sort function. You can create your own types of sort, and you can say, I have this weird sorting mechanism, use that. JavaScript actually doesn't care what the algorithm for sorting is, but if you don't specify, it will use its default, which is lexicographic sorting. And of course, if the values are numbers, it actually uses numeric. Yeah. So yeah, let's see now how we do this sorting. And you see, like, so each column can either, so here is a good point to like talk about different values of this sorted keyword we added. So for example, here field language, this column has sorted key set to null, whereas for price name column, the sorted key is set to DSC, which is descending. Like, you can use anything you want. I just use DSC. When it's ascending, we use ASC. And now let's see how to switch between these three values: ASC, null, and DSC. By default, when we just run our code, no column has anything appended to it. So the data set is just rendered as is. It's not sorted by any value. And now let's take a look at how we actually create this table. So we like create our div, append a table, append header, body, and now we basically refactored our code to where the actual rendering is done by this draw table function, which takes in the data set and the columns. And the initial data set we give this draw table is the subset which we were rendering earlier, and then the list of columns. And inside this draw table function, our basically our header is rendered exact same way: select all th, bind it to this calls. Instead of using columns directly, we take columns as a parameter to the function, and we'll see why we do this. Then we join our th. Then the text value is, now instead of using d dot title directly, what we say is, if our data set, if this column is used for sorting, append the title with the kind of the first letter of the sorted state, which is either ASC or DSC, so either A or D. So this is basically saying substring of sorted. Like, sorted is a string, right? So we are saying use the first character and make it uppercase. And if basically if the column is not sorted, like if that particular column is not sorted, just use title directly. Don't append anything. So we basically end up with either this year or year hyphen A or D, depending on what the status is. And again, at this point, we haven't specified how we change this sorted key, right? We are just saying if it is, use it. We'll see how to do this. So first thing, before we actually like do anything with the header, let's just render our rows. The code for that is straightforward. Like, select all tr, bind it to our data set, which is basically what the first input to the draw table. Then for each row in the dataset, join a tr. Then then we actually start appending the individual cells using object.entries. And the code, like, till here is really simple. All we have done is basically change this one line from our existing code. So now here is where we actually add our interaction for sorting. So what we say is, for the header row, on click, call this function, and this is our sort function, or this is the logic for sorting. And what it does is, the first line, basically when you click on any of the column, the first thing we do is we iterate through. So this filter function basically checks for any column except the one that is clicked, and sets it sorted to null. So for example, let's say now we have sorted by year. If we click on category, the year should be set to null. That is what this line of code does. It changes the sorted status of other columns to null, and then we operate on the current column. So on the current column, we first check if the current column is not sorted in ascending order, we just sort it by ascending order. So we actually take our data set, do the dot sort function, and we kind of just do this comparison. uh, a the d dot title specifies the column we have clicked on. So we just, for the column we have clicked on, we take the value from A and we take the value from B, compare them. If they're less than, like if the value of A is less than B, return -1, else 1. This is the sort logic. And This less than by default uses lexicographic comparison. And what JavaScript does is, for all the pairwise objects in the data set, it passes them to A and B. So it takes the first two elements, passes it to this sort function, and kind of compares and sorts the entire data set. And you can replace this basically with any logic, as long as you return either a number greater than one, basically a number. So it uses kind of this numeric comparison, right? Greater than one or less than one. So yeah, this is the sort function, and this is the how we sort in ascending way. And this is quite like, this is like the most basic thing you can do. This basically is not even checking for the data types. It just like saying A less than B. If it is string, JavaScript will figure out what that means. And in, like as I said, it is lexicographic. And then since now we sorted in ascending order, we set d dot sorted to ASC, because we checked it wasn't ASC. And what this means is, when sorted wasn't ascending, what we are saying is it was either not sorted at all or it was in descending order. It doesn't matter. As long as it wasn't ascending, set it to ascending, because that's the first sort we want. And then we actually draw the table again using the new data, which is the sorted data, and the old columns. And the other condition now, if our data set was already in an ascending order, then we basically check if our data is sorted in an ascending order, sorted with the descending order. Basically, we just inverted our comparison. We said d dot sorted to descending, and then we redraw the table. That's it. So basically, this logic kind of just handles your sorting of different columns and kind of basically switching between them. So this is a category is a wrong example, because we took a subset, everything here is piece. But we can see on the other places, like the sort works, and if we keep clicking, it keeps switching. But if we switch to something else, it always starts with an ascending order. And like you can do so, basically you could also, like, this line of code makes sure that at a time the entire data set is only sorted by one column. If you remove this line of code, you will have access to sort state of other columns also. So for example, you could say first sort by birth date and then sort by birthplace. You could do that, but it's slightly complex and it's never really that great of an idea to do in a tabular visualization. If this was like some other, yeah, please. No, it's not. You can specify it to sort by date. So basically here you have access to, like, when you do this, here you can write some logic to kind of check if the column is like birthday, if the column is date, then you can convert it to date and then compare. Right now it is treating it as a string and using lexicographic comparison. It's not ideal, but it it works, because like for the end year, it like, if you see, like, it doesn't work mostly because like it checks 18 and 19 and just sorts it that way. It doesn't even go forward. That's how lexicographic comparison works. It's not a great way to handle this. It would work for numbers mostly, yeah, because it, like, numeric strings it works for. But I would recommend like having some control here. And a really good way to kind of do this is, we can actually go here where in the top, when we actually convert this, wait, where was that code? Yes, here we have title sorted. Here we could add a third column called, let's say, type, and basically write some code here to figure out type. Is it a number, is it a text, or is it a date? And then using the d dot type, customize our compare function at this step. So then now here we could write our, like, here we could change our code to be like, if d dot type, then do like whatever comparison based on the type you want. So yeah, it's kind of up to you, like how to do that. But by default, yes, it doesn't really consider, it's like JavaScript is not really smart at this. But yeah, that is pretty much it on how to create tables, like slightly good looking tables with some interaction added to it. And usually like sorting is kind of the only interaction you would add on a table. You could do complex stuff. Like another type of interaction we really ask you to do in the in your homework is expanding the individual rows. So you can think of that like the README gives you a hint, right? Basically, when you expand, you can think of it as adding new rows to the table. And of course, using the D3 syntax, adding rows is really easy. Enter, exit, update. You can use the logic to update your existing table. And the click event for expanding and collapsing will look very similar to the click event for this. Instead of clicking on columns, you have to do on click on the rows. That's it. So this is pretty much what we have for today's homework lab. Any questions on this? Meanwhile, like we have finished the lab for the table, so I will kind of stop streaming